My name is Balkcom, and I'll be talking about the Summer Robotics Camp. A human being has great hardware. We've got 2 hands, 2 arms, touch-sensitive skin. But without a brain, there's not much we can do. Robots are in the same circumstance. But without understanding computing and the way that we need to model the physical world and interact with the physical world mathematically, we're unable to make a robot to do anything effective. One of our goals is to really emphasize the importance of computing as we move into the future and give people the skills that they need to understand what's out there. At the robotics camp, the students get to work with real robots. The camp's been running for 6 years, and it's available for students that are either middle school or high school age. There's actually a loose conglomeration of camps. They're all called the Robotics Camp, but we offer several sessions per summer, and they all teach different skills. And this ranges from basic engineering skills and excitement about putting things together, doing some building of robots either with Lego or other kits at one level, up to a different level, which is taking a robot that's already functional and programming it to do something exciting. Some students are more excited than others. Some have different backgrounds than others. Some have a lot of experience in programming. Some have never programmed a robot or built one. And what's very exciting about the camp is that by the end, everybody's making something work. Some of the things that students have done in my camps over the last few years include mobile robots. They've programmed some robots that are initially automatic vacuum cleaners to run around in a maze and to chase each other. The idea is to learn something about exploration while they're also learning something about programming. We've also done some work on robot arms, and they've used a $20,000 industrial robot arm to do a little bit of drawing. There are a lot of different things that the students do in this camp, and some of them are very much engineering skills, putting a robot together. Others are programming, making the robot move around in the maze. But we also want students to start thinking about computational techniques to model the physical environment and control that with a computer. There's a lot of exciting things that can be done here. For example, one year we had robots actually use the robot arm to build structures out of Legos. And one of the components is that error builds up as we move through this process. How do you model that error is a question they start thinking about at a very early stage. We want to encourage underrepresented minorities and everybody, in fact, to get involved in science, technology, and computing. And unfortunately, in computer science, women are still a minority. So something we're very excited about is the Girls Only Camp. This provides an environment where women instructors can work with young girls about something that they're excited about as undergraduates or graduate students, and show that this is really a field that is open to everybody and has a lot of potential. Some of the students will perhaps become computer scientists or roboticists. I hope all of them. But that may not happen. And as they move into some other field, science or the arts, humanities, they're going to see some of the opportunities that are out there based on this initial experience with technology and the ability to program, which we believe is a basic component of technology literacy. The Newcomb support allows us to pay a small stipend to our instructors, pay for small robots that we use to drive around in the camp, and also allows the camp to be free so that students of all backgrounds can participate. We want to really give the opportunity for students to learn some programming that can be used beyond just robotics and take that home with them. Once they've got that programming skill, they can use it for whatever they imagine.